Good evening, ma'am.
Yeah, good evening, Rahul. Rahul, I just, was telling the class about lines and angles and Euclid's geometry. You will get the details on WhatsApp. I don't want to repeat because you just joined the class. We'll just get started. All right. So details regarding lines and
Okay, ma'am.
angles and Euclid's geometry will be given on WhatsApp. Okay. So today we are starting this new chapter, congruent triangles. All right. Let's first understand how a triangle is formed in a plane. All right. So to form a triangle in a plane, we need 3 points. We need 3 points. So supposing we have the 3 points like this. We have the 3 points like this. So we have 3 points in a plane. Now let's try to form a triangle using these 3 points. No triangle is formed. We have 3 points because we know a triangle has 3 vertices. Okay, so 3 points we need to form a triangle. We have 3 points, but no triangle is formed because the points are collinear. Because the points are collinear. We have 3 points, but since the 3 points are collinear, that is, they can be connected by the same straight line. So no triangle is formed. Now, 3 points. The 3 points are not collinear. They're not collinear. The 3 points cannot be connected by the same straight line. Then a triangle is formed. So a triangle is formed by 3 non-collinear points in a plane. A triangle is formed by 3 non-collinear points in a plane. If you have 3 points, the 3 points may form a straight line or a triangle. The 3 points, when you connect the 3 points, it may form a straight line or a triangle. If the 3 points are collinear, it's a straight line. If they are not collinear, a triangle is formed. Okay. So we know that a triangle has 6 parts, 3 angles and 3 sides, 3 interior angles and 3 sides. So one triangle has 6 parts, 3 angles and 3 sides. Now, when we talk about congruency, okay, or congruent triangles, the term congruent means identical. Identical. Okay, so say you take photographs of yourself. So photograph you can have in different sizes, right? You call it the stamp size photo, passport, passport size photos, postcard size photos. Okay, there are different sizes. So when you go to a studio to click a picture of yours, you should tell the photographer the size you want. So he'll ask you if you want. You have different dimensions today. Okay, so in my days it was only stamp size photo or passport size photo or postcard size photo. Only these three we had. So now we have different dimensions. Well, we'll not go into all that. Now, when you look at the stamp size photos of yours, they're all identical, right? Now you'll tell them like you want say some 10 stamp size photos of yours. So when you look at all the 10 stamp size photos of yours, click at a particular time, not different stamp size photos of yours. So one picture graph, one photo, and 10 stamp size photos. Stamp size, one small stamp, the size of a stamp. Okay. Yeah. So all those 10 stamp size photos are identical, right? So they're congruent photos of yours. They're all congruent photos of yours. Because in every other photo, you look the same. So congruency is basically a state of being identical. When two things are, when one is exactly like the other, or when two things are identical, they are said to be congruent to each other. That's all it is. When two things are identical, exactly the same, identical in every aspect, then they are said to be congruent to each other. Okay, so when we say congruent triangles, two triangles are said to be congruent. If one is exactly like the other, if one triangle is exactly like the other triangle, they're congruent triangles. So which means if you have the cutouts of the two triangles, say you have paper cutouts of the two triangles. When you place one triangle over the other, they'll coincide. The triangles will coincide. But you should place them in a particular way. See, now supposing now this triangle and this triangle, they're identical. Okay, they're identical. Now, if you place this one over this like this, okay, they'll not coincide. They are identical, but you're deliberately placing it in a different way. You should place them in a way they coincide. So you must rotate and make the corresponding vertices or the corresponding sides sit on one another. So you may have two identical triangles, but if you place them like this, you understand this positioning? Yeah, you have one with the vertex up here and the other with the vertex down here. Then obviously, though they are identical, you're being tricky. You're not placing them correctly. So even when two things are identical, you need to position one over the other in a particular way so that they coincide. They'll not just coincide. If you simply put it like that, they'll not coincide. You should carefully position one triangle over the other triangle. You must make the vertices, corresponding vertices match. Okay, you should position the vertices correctly. Only then they will coincide. And you can see that, they are identical or congruent to each other. So even if you have two identical things, if you don't place them correctly one over the other, so now you have a photograph of yours like this. Okay, another photograph, same photograph you have like this. But if you have one like this and the other you put it on it like this, they are identical photograph of yours. They are identical photographs of yours, but if you place them like this, how will they coincide? So you should turn it and you must put this on this in this way. If you turn it like this and put it in this fashion, yeah, they don't coincide. So you may feel that they are not congruent, but actually they are. Okay, so that's about congruency. When two things are identical, when two triangles are identical, they're called congruent triangles. So when we say identical triangles, the angles, all the angles of one triangle will be equal to the corresponding angles of the other triangle. And all the sides of one triangle will be equal to the corresponding sides of the other triangle. Okay. The three angles of one triangle will be equal to the corresponding three angles of the other triangle. The three sides of the first triangle will be equal to the corresponding three sides of the other triangle. Now, we have something called the congruence criteria. Okay. Congruence criteria. Criteria is plural for a criterion. Criterion. Criteria is plural. Criterion is singular. Now, what are these congruence criteria? So now when you have to, theoretically, without actually measuring and all that, if you want to theoretically like work and prove that two triangles are congruent. So you're not supposed to use protractor to measure the angle or scale to measure the side. Okay. So using some information given, if you have to show that two triangles are identical or congruent, okay, you need some basic information, basic meaning some minimum information to show that they are congruent. So we need three pairs of equalities. We need three pairs of equalities. Like this angle of the first triangle is equal to this angle of the second triangle. This side of the first triangle is equal to this side of the second triangle. So you need to have three pairs of equalities. Equalities can be equal pairs of equal angles or pairs of equal sides. equal angles, one angle equal to another angle, or one side equal to another side. Okay. So like this, you need to have three equalities. Okay, so that minimum thing you need to show that the triangles are congruent to each other. So they are given those minimum things which you need to show the two triangles are congruent are given through these 5 congruence criteria. Those 3 minimum equalities which we need to show that two triangles are congruent to each other are listed in the form of congruence criteria. So we have 5 different congruence criteria. The first one being SSS congruence criterion. Each one is criterion. Okay. One is congruence criterion. All together is congruence criteria. All right. And then we have the SAS congruence criterion. We have the ASA congruence criterion. We have the AAS congruence criterion. And then we have the RHS congruence criterion. This can be the simplest chapter because everything will be given in the question. You just have to pick the equalities, arrange them so that they form a congruence condition, and then say that, yeah, see, these 3 things are equal, so they are congruent. That's all. So not much of a strain here. So mostly everything is given. Mostly everything is given, or maybe with the help of what is given, you'll have to find some simple information and then show they are congruent. But on the whole, it's, this chapter is very simple because you cannot get a lot of variations and all that. Like mostly we have some set of standard questions which are asked. So in that sense, you know the boundary. Idallam padicha, okay, I can do well enough. When compared to the numericals, like in rationalizing the denominator, you can get different kind of questions. So like that. So in that sense, so you can just relax. This chapter is very simple. But understanding the basics is very important. If you understand now this introduction clearly, then the rest of the chapter is easy. If here you have trouble, please get it clarified now. All right? And don't sleep in the class. Okay. So if you're not attentive, we cannot understand. I know how many of you are attentive. So if you're not attentive, nobody can help you. Nobody can force you to be attentive. Nobody can stop you from being attentive, right? Nobody can stop you. Even in a lot of chaos and noise, you can still be focused and attentive. So it's all your choice. So these are the 5 different congruence criteria. So what are these? See, SSS. A pair of, that is 2 sides equal, 2 sides equal, 2 sides equal. That means when all the 3 sides of the first triangle are equal to the corresponding 3 sides of the second triangle, we don't have to check the angles at all. You don't have to check the angles of the 2 triangles. If the 3 sides of the first triangle are equal to the corresponding 3 sides of the second triangle, then the 2 triangles are congruent. They are identical by the SSS congruence criterion. So see, we checked only the sides. What about the angles? You don't have to check. With this minimum thing, you can be sure that the angles also will be equal. The corresponding angles also will be equal. You don't have to check the angles. So of the 6 pairs, of the 6 things, like you have 3 equalities with angles. See, like if these are the 2 triangles, so A, B, C, P, Q, R, angle 1, angle 2, 3, 4, 5, 6. Suppose say this side is equal to this side, this side. Okay. So if you know that AB is equal to PQ, that is 1S. And BC is equal to QR. And AC is equal to PR. then these two triangles are congruent by the SSS congruence criterion. You must say a side of the first triangle is equal to a side of the second triangle. You must know, if you write AB is equal to AC, okay, AB may be equal to AC, but that is not an information. You must say one side of the first triangle is equal to another side of the second triangle. You cannot say two sides of the same triangle are equal. That is not an information. You're comparing the two triangles. So it should be one side of the first triangle is equal to a side of the second triangle. So AB is equal to PQ, that is an S. BC equal to Q. It need not be in this order. It can be a different order. Like it can be AB is equal to PR also. It can be BC is equal to PQ. That's okay. It need not be like this side should be equal to this side only. Not that. Okay. So if you have, like in this case, AB equal to PQ, BC equal to QR, and AC equal to PR, then the two triangles are congruent by the SSS congruence criterion. Now, what about the angles? Automatically, now that the triangles are congruent, automatically angle 1 is equal to angle 4, angle 2 is equal to angle 5, angle 3 is equal to angle 6. When you prove that two triangles are congruent using one of these rules, then the remaining equalities which you did not know are also true now. What are the remaining equalities? Like 1 and 4, they should be equal. Yeah, now they're equal because the triangles are congruent. So their corresponding angles will be equal. So this angle is equal to this angle. Angle 2 is equal to angle 5 and angle 3 is equal to angle 6. All right. So we say, how do we define this? When three sides of one triangle are equal to the corresponding three sides of the other triangle, then the two triangles are congruent by the SSS congruence criterion. This one, when two sides and the included angle of one triangle are equal to the corresponding two sides and the included angle of the other triangle, then the two triangles are congruent by the SAS congruence criterion. This is when two angles and the included side, when the two angles and the included side of one triangle are equal to the two angles, corresponding two angles and the included side of the other triangle, then the two triangles are congruent by the ASA congruence criterion. This is when two angles and any side of one triangle are equal to the two angles and the corresponding side of the second triangle, then the two triangles are congruent by the AAS congruence criterion. This is in two right triangles. RHS meaning right angle hypotenuse side. Right angle hypotenuse side. All right. So this is in two right triangles. So right triangles meaning we already have one pair of equal angles, 90 degrees, 90 degrees. Both are right triangles, right? Both are right triangles. So we already have one pair of equality, 90 degrees. In the first triangle, one angle is 90. Second triangle also one angle is 90 degrees. Okay. Then H is hypotenuse. The hypotenuse in both the triangles must be equal. And any side of the first triangle should be equal to the corresponding side of the second triangle. So right angle, hypotenuse, side. Now, when we apply all this in a question, it will be better. It will be, meaning you will understand still better. I will not talk about the criterion just like this. We'll take a question, we'll answer that, and I think that will help you to understand better. Now, AAA is not a congruence criterion. AAA. This one is not a congruence criterion. Because consider two equilateral triangles. Consider two equilateral triangles. Okay, so this is an equilateral triangle with each side 5 centimeters. This is an equilateral triangle with each side 8 centimeters. All right. Now, this angle is 60 degrees. In every equilateral triangle, each angle measures 60 degrees. Now, if you say that in these two triangles, the angles are equal. All the angles of this triangle are equal to the angles of this triangle. Are they identical, the two triangles? No, one is small, the other is big. How can they be congruent? When you have two triangles of different sizes, you don't need any information. Just by looking, you can say, how can you say that they are identical? Okay, a baby elephant and a father or mother elephant, how can they be, congruent to each other? Right? They directly, obviously, they have different sizes. Congruency is being identical, one exactly like the other. So one small triangle and one big triangle. You should say, don't give me any information. When I see, you can just see and say they are not identical. No, so they're not congruent. This is small, that's big. So when you consider two equilateral triangles, in every equilateral triangle, each angle will be 60 degrees. Now, are they congruent? No, this is small. 5 centimeters is smaller than 8 centimeters. So AAA, angle is not a valid congruence criterion. SSS is a valid congruence criterion. But see here, 5 centimeters, 8 centimeters, they're not equal, no. So SSS is not true here. See, this is 5 centimeters, this is 8 centimeters. 5, 8, 5, 8, sides are not equal. Sides are not equal, no. So SSS is not true here. So the two triangles are not congruent. But if you think, let me use AAA. This angle is equal to this angle. This angle is equal to this angle. This angle is equal to this angle. AAA. So they are congruent. No, that's not a valid congruence criterion. So in all these congruence criterion, we have the basic three equalities. The minimum three equalities which are required to be checked to show that the two triangles are congruent to each other. Okay. SSS, SAS, two sides included angle. ASA, two angles included side. AAS, two angles, some other side, any side, yeah. RHS, right angle, hypotenuse side, any side. Now let's understand what's meant by included angle and included side. Okay. Now we're trying to understand the included angle. Included angle. What is meant by included angle? Now we know that an angle has two arms. An angle has two arms. Angle. Okay, this is one arm, this is the other arm. Now, if you look at, meaning if you consider these two sides as the arms, then which is the angle? Which vertex is the angle? Where is the angle formed? If you, excuse me, if you consider this side AB and this side BC as two arms, then which is the angle? Angle B. Angle B. Angle B is the included side. For these two sides, angle B is the included angle. For these two sides, angle B is the included angle. Included angle is the two sides which we are talking about in one triangle. The two sides which we are talking about in one triangle must be the arms of that angle. Not clear, Surya? I'm not clear? Yeah. No. What do you mean by arms? See, this is the angle. This is the angle. Okay. This is one arm. This is the other arm. Now, when we talk about this side and this side, these two sides are the arms of this angle, right? So angle B is the included angle. Yeah. Now in the other triangle, when we talk about this side and this side, that is, when we talk about the sides QR and RP, which is the included angle? This is the included angle. Angle R is the included angle. The two sides will be the arms of a particular angle. That is the included angle. The two sides you're talking about in one triangle will be the arms of that angle, which is called the included angle. That's all it is. Now, let's understand included side. Included side. So say in this triangle, you're talking about angle 1 and angle 3. And in this triangle, you're talking about angle 4 and angle 5. Okay. In this triangle, you're talking about 1 and 3. See, I'm explaining like this, but you don't have to think about all this to identify the included angle inside. Just by looking at the diagram, you can say. I'm just telling you the theory behind it. Otherwise, you don't have to run all this theory in your mind and then, okay, this is the included angle. No. Just by looking, you can say which is the included angle or included side. You will learn to say that. Now, in this triangle, if we are talking about angle 1 and angle 3, which are the arms of angle 1? Which are the arms of angle 1? This one and this one are the arms of angle 1. Which are the arms of angle 3? Angle 3. Which are the arms of angle 3? This one and this one are the arms of angle 3. So which is the common arm now? This, okay, one. Which is the common arm? AC. AC is the common arm. That is the included side. That's the included side for angle 1 and angle 3. When you talk about two angles, each angle has two arms. Angle 1 has two arms. Angle 3 has two arms. That common arm is the included side. The common arm is the included side. So in triangle ABC, for angle 1 and angle 2, when we talk about angle 1 and angle 2, AB is the included side. Very easy, just like that you can say angle 1, angle 2. Like where is angle 1 at A? Where is angle 2 at B? So AB is the included side. So if I have to explain why, this is what it is. Because AB is the common arm for these two angles. Because which are the arms? Which are the arms of angle 1? Angle 1. Arms are AB and AC. Now take any other angle. Angle 2. Arms are AB and BC. So for angle 1 and angle 2, AB is a common arm. That's it. So for angle 1 and angle 2, AB is the included side. So now tell me, which is the included side for angle 2 and angle 3? Which is the included side for angle 2 and angle 3? BC. Which is the included side for angles 1 and angles 1 and 3? AC. Which is the included angle for the sides AB and BC? Included angle for these two sides. For AB and BC, which is the included angle? Angle 2. Angle 2. Which is the included angle for sides BC and AC?
Angle 3.
Angle 3. 3. Which is the included angle for sides AB and AC? AB and AC. Angle 1. So this is about included sides and included angle. Let's just see if I'll just try to explain this. I think it's enough what we understood. If I'm able to help all of you understand this, then we can continue. Meaning it doesn't need any more explanation. Let me just check that. Now in this figure, OA, you can see it's marked. OA is equal to OB. Can we see it's marked here? See it, OA, it's marked, is equal to OB. Okay, OA is equal to OB. OD is equal to OC. That also is marked. OD is equal to OC. The two lines. OD is equal to OC. Like this, it's marked, no? Okay. Now with this information, you will have to show that triangle AOD, this triangle is this is, yeah, I forgot to say this. So this is the symbol for congruency. Congruency, an equal to sign and whatever you call S or a wave like thing. All right. Okay. So you'll have to prove that when in print, it's like this only. It is like this, but you'll just see it like three lines like that. That's congruency symbol. Okay, you'll have to show the triangle AOD. Triangle AOD is congruent to triangle BOC. And you should also prove that AD, this one, AD is parallel to BC. AD is parallel to BC. See, now you might know how to do it if you've already learned in school. But listen like as if you don't know. How is that possible? Huh? Yeah. Okay. So first you should write what is given. When it comes to proofs like this, first there is a format in which you will have to present the answer. First, you must write what is given. What is given? A is equal to OB. Then OD is equal to OC. Before this, you should write given triangle AOD and triangle BOC. We are given two triangles. And OA is equal to OB. Let me write it still small. Okay, sorry. Given triangle AOD and triangle BOC. We also given OA is equal to OB and OD is equal to OC. Now to prove that, show that meaning to prove that, you can write TPT to prove that. This is not my short form. So this is acceptable. Okay, so TPT. So to prove that triangle AOD is congruent to triangle BOC, and you should also prove that AD is parallel to BC. Now we must say proof. Now you should mention the two triangles in triangle AOD and triangle BOC. And then you're going to write three things. Okay. Now we are going to first decide the congruence criterion. It is not RHS because they're not right triangles. They may be right triangles, but it's not given. So no, RHS we cannot use. So it should be one of the remaining four. Now we have two pairs of equal sides, right? Equal sides. So that means you have SS. This is one S and this is the other S. So that means it can be SSS or SAS. It can be SSS or SAS only. Correct? Because you have two S. So the third thing can be a S or it can be SAS. Now for SSS, you should need another pair of equal sides. That is, you must have a BC equal to AD. If it should be SSS, you should have BC equal to AD. No, that is not given. So it cannot be SSS. It has to be SAS. So the rule is SAS only. The rule is SAS. So write that. Sometimes you can make out like this. So when you know it, you can just write it. In a pencil, you can just write SAS here. Now, see here. Which is our first triangle? You can take anything as the first triangle. Say I take this as the first triangle. This one is the second triangle. Okay. That's what I've written here. AOD I've written first, and then I've written BOC. All right? Okay. Now, listen to this. OA, side OA of the first triangle is equal to side OB of the second triangle. Am I saying that? No, it's given. It's given right on top that OA is equal to OB. OA is the side of which triangle? The first triangle is equal to OB, which is the side of the second triangle. So this is a valid equality because you're saying one side of the first triangle is equal to another side of the second triangle. Yeah, you can. This is how you should write. What is the reason? Given. This is given. Now the other equality given is OD of the first triangle. See the figure. OD of the first triangle is equal to OC of the second triangle. Correct? Can we see OD is the side of the first triangle? OC is the side of the second triangle. They equal. It's given. Now, please listen. These are the elements of the first triangle or the sides of the first triangle. These are about the second triangle. These are about the second triangle. Okay, that's very important. So discipline is very important. These should be of the first triangle. These should be of the second triangle. You can take this. You can take anything as the first triangle. You can take this as the first triangle. This as the second triangle. That is your choice. But whichever you choose, the information regarding the first triangle here after the equal to sign, information regarding the second triangle. Now this is important. Now OA OD. Go to the figure. Go to the figure. OA OD. These are the arms of which angle? OA and OD. O. They are the arms of this angle, right? Let me mark 1 and 2 like this. Triangle 1, triangle 2. I'm saying OA and OD. I'm asking OA and OD are the arms of which angle? Angle 1. Correct? Now, the other one, OB and OC, what I've circled, OB and OC of the second triangle. OB and OC are the arms of which angle? OB, OC. They are the arms of which angle? This angle. An angle has two arms. To see it. These are the two arms. So this is the angle. Are the arms of this angle. Let me mark 2. So these are the included angles. These are the included angles. So you must write angle 1 is equal to angle 2. The reason is not given. Vertically opposite angles are equal. Vertically opposite angles are equal. That was not given to you. But anywhere we have intersecting lines, vertically opposite angles will be equal. That need not be given. Wherever you have intersecting lines, vertically opposite angles are equal. So angle 1 is equal to angle 1 of the first triangle is equal to angle 2 of the second triangle. So this is how you present the equalities. This is how you present the equalities. Therefore, now the other very important thing is how to name the two triangles. How to name the two triangles. You cannot, now this triangle AOB, no? Sorry, AOD, the first triangle AOD, you can call it AOD. You can call it ADO. You can call it you can call it DAO. You can call it DOA. You can call it OAD. So many ways, right? You cannot write however you want. Or I cannot write it however I want. When once you show that the triangles are congruent, you must name the triangles in a specific order. The vertices must be used in a specific order. We'll understand the order now. Okay, so we cannot just name it however we want. Now look at this one. Look at this one. Do we have OA and OD there? We have. Which is the common vertex? O, no. That letter O is common. Now, this first side, this is your rough work. This is your rough work. You write out these two sides in the rough column. This O is the common letter. What you do, this one should end with a common letter. This one should start with a common letter. OA, you write it as AO. And OD, AO, OD. So AO, OD, no. So the triangle is AOD. Now here we have OB and OC. We have OB, OC. O is common. So this one you write, it should end with that common letter. This one should start with the common letter. So the triangle is BOOC. 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 But how many times will you write one vertex? So BOC. BOC. This is the order. So you must say, I haven't finished. So we should say triangle AOD is congruent to triangle BOC. So if you have paper cutouts of these two triangles, you must place the triangles in such a way that vertex A coincides with vertex B, vertex D coincides with vertex C, and vertex O coincides with vertex O. Only then, the two triangles that coincide. If you place vertex A on vertex C, no, then if you do that, they are identical triangles, but they'll not coincide when you place them one over the other because you have not placed by matching the vertices. You've simply placed some, like the way you want. You have not matched the vertices. So you must, when you place the two triangles one over the other, you must place them in such a way that the vertex A or the side AO coincides with this side coincides with this side coincides with this side, and AD, this side coincides with BC. It's easy to match the vertices than the sides. Now, what are the other variations? Is this the only way? Should I only write AOD congruent to BOC? Is there any other way? Yes, there are many other ways. Once you identify one correct way of naming it, now you can change it. See, you can write, if you want to write, is this part understood, children? How to name the triangles in the correct way? If you write this correctly, we further will get, we'll infer results from this. நீங்க இந்த ஆர்டர் கரெக்டா இருந்தாதான் further results நீங்க கரெக்டா எடுக்க முடியும். Otherwise, you will go wrong. So this part is like not taught in school or something. So each teacher will teach you in a different way. Some teachers won't even say how to write it in the correct order. She'll just write because there she'll say just write whatever is given here. They write it off. What is given here? Write the same thing. So each one has their own way of expressing. So this is how I say. Okay, and I hope I've reached all of you. Now so this is one way of naming it. Now you can also name it like if you say OAD, then it is congruent to, you said second vertex 213. No, here also say 213 OBC. Let me number it 1 2 3 1 2 3. Then I'll just number it. Okay, this is 1 1 2 2 3 3. So if you say 213 here, 213 here also I should say 213 OBC. Here if you say 312 or okay 312, that is 3 is D, 1 is this one, 2 is this one. If you say 312, here also you should say 312, that is CBO. All these orders are correct. All these orders like this you can write it in different ways. All these orders are correct. So there is not one correct way of naming the two triangles. You can write them in many ways, but it should be the correct way. If you write triangle DAO is congruent to COB, you're wrong. If you place vertex D over C and A over B, clearly they will not coincide because O should go with O. But according to your order, A and O coincide. They will not actually coincide because O should coincide. Okay. So you just write one order, okay? So this is the order. So how I explain this is, I'll just do it once again, fast. I said in the rough column, write out, these are the sides of the first triangle, OA and OD. I said, let it end with the common letter. Let the first one end with the common letter. Now you will ask me, should I write OA first and then OD? No. You can write OD first and then OA also. Right? Any side first. Then write the next side. So what's the common letter? O. So let this one end with a common letter. Let this start with a common letter. The second one also, you can write OB first, and then anything you write first and second. That's not, this should end with a common letter. This should start with a common letter. So what's the name of the triangle here? BOOC, BOC. This is DOOA, DOA. So DOA, triangle DOA is congruent to triangle DOC by the SSS congruence criterion. See here, this is the correct order actually, no? So DOA, see DOA, A. So it should be C. If you say DOA, oh my God, what am I getting here? Oh, sorry, I changed the sides here. I changed the sides here, I'm sorry. I wrote OD first, but the bottom one I wrote first. OD and OA. I wrote the bottom one first. OD and OA. So OD goes with OC, no? So OC. I wrote the bottom one first. OD I wrote first, and then I wrote OA. So the bottom OD goes with OC. So OC and OB. So OC is CO, and this is OB. So it will be COOB, COB, COB. So you can see, compare the two. Compare the two. Yeah. Okay. Now compare the two. DOA. See here? DOA. POC. Sorry, COB. Now I'm saying both are the same. See here? This is AOD. Backwards it's DOA. This is BOC. Backwards it is COB. Both are the same. All right. Like this is 1, 2, 3. 1, 2, 3. We have written 3 to 1. DOA 3 to 1. So here also you should write 3 to 1. 3 to 1. COB. Normally we just copy like whatever is given here, we'll just write that. But sometimes if there's a printing mistake in the question paper and you just write that, so you may not be able to get the results. Rarely. So it's always better you decide, you check if that order is correct. You write what is given in the question paper, but you check if that order is correct. So we'll write what is given there, that order is correct. So we'll just write that. Therefore, triangle AOD is congruent to triangle BOC by the SSS congruence criterion. We proved the first part. Now we'll have to prove that AD is parallel to BC. Always remember, we have only three ways to show that two lines are parallel. There are 3 ways to show that two lines are parallel. You should either show that a pair of corresponding angles are equal, then the lines are parallel. Or a pair of alternate interior angles are equal, so the lines are parallel. Or a pair of allied angles which are supplementary, co-interior angles that are supplementary. If you can show that a transversal intersects two lines in such a way that corresponding angles are equal, then the lines are parallel. A transversal intersects two lines in such a way that a pair of alternate interior angles are equal, then the lines are parallel. Or if a transversal intersects two lines, I'm not saying parallel lines, if a transversal intersects two lines in such a way that allied angles are supplementary, then the lines are parallel. So here we are going to mark off this angle and this angle, or you can use this angle also. You can use, this is the first triangle, no? So this is 3 and this is 4. Now let me identify a Z from here, okay? I'm going to identify a Z because we know that alternate angles are formed in a Z or that Z shape rotated. Okay, so is there a Z like this? Yes. Now the Z is C, B, A, D. Now tell me the angle numbers here and here. Angle 3 and angle 4. Now angle 3 is letter vertex A. Angle 3 is vertex A and angle 4 is vertex B. Now come back to this order, okay? Just see if A is a vertex of one triangle. This B is the vertex of another triangle, of the second triangle, right? Now see if this vertex A is equal to the vertex B. Vertex A, yeah, both are in the first position. Yeah, so angle A is equal to angle B. Angle A of the first triangle is equal to angle B of the second triangle. Angle O of the first triangle is equal to angle O of the second triangle. Angle D of the first triangle is equal to angle C of the second triangle. And then AO is equal to BO. OD is equal to OC. And then AD is equal to BC. Triangles are now identical. Their corresponding sides and angles will be equal. Okay. Now we identified a Z. That's the first thing. Now in the Z, we have two angles, angle 3 and angle 4. Angle 3 is at vertex A. Angle 4 is at vertex B. Now we are coming back to the names of the two triangles. We're just checking if A is equal to B. Yeah, A is in the first position, B is in the first position. Yes, angle A is equal to angle B. That means angle 3 is equal to angle 4. Angle 3 is equal to angle 4. Why is angle 3 equal to angle 4? You must say CPCT. CPCT. Corresponding parts of congruent triangles. Corresponding parts, not the corresponding angles, not that corresponding, matching angles. Don't get confused with alternate angles, corresponding angles, not that corresponding. Matching angles of the matching parts of the two triangles, of the two congruent triangles. Okay, so in that sense, corresponding. So angle 3 is equal to angle 4. Corresponding parts of congruent triangles are congruent, they're equal. So CPCT. But see, we got the result angle 3 is equal to angle 4. Or you can also write angle 5 is equal to angle 6. See, if you consider this Z. What is the vertex here? Surya, what is the letter here? D here. Here. B here. And number. Vertex. D. Vertex C. See if D vertex of the first triangle, vertex D of the first triangle is equal to vertex C of the second triangle. This is in the third position. So in the third position here, this one. Yeah, vertex D of the first triangle is equal to vertex C. Or vertex D coincides with vertex C. That means angle D, the angle formed at vertex D is equal to the angle formed at vertex C. Angle formed at this vertex D is equal to the angle formed at this vertex C. Yeah, so angle 5 is equal to angle 6. Why? Don't say alternate interior angles are equal. The lines are not parallel. You can't say alternate interior angles are equal here. Angle 5 is equal to angle 6 because the two triangles are congruent. They're identical triangles and their corresponding parts are equal. This is not alternate angles are equal. Because alternate angles you can say only when the two lines are parallel. Now we don't know if AD is parallel to BC. So angle 3 is equal to angle 4, reason CPCT. Angle 5 is equal to angle 6, reason CPCT. Now if you write any one of the two, so if you write angle 3 is equal to angle 4, you must say, but angle 3 and angle 4 are a pair of alternate interior angles. They are a pair of alternate interior angles made by which transversal? Made by which transversal? Sorry, AB made are a pair of alternate interior angles made by the transversal AB with the lines. Yeah, with the lines AD and BC. AD and BC. And they're equal. and are equal. And are equal meaning and the alternate angles are equal. That means these two lines, AD and BC, should be parallel to each other. Because alternate angles are equal, no? They'll be equal only when the lines are parallel. But we didn't say angle 3 is equal to angle 4. Reason is not alternate interior angles. Angle 3 is equal to angle 4 because the two triangles are congruent and their corresponding angles are equal. But they are a pair of alternate interior angles made by this transversal with these two lines. So since the alternate angles are equal, the lines should be parallel to one another. Therefore, AD is parallel to BC. AD is parallel to BC. The same thing you can say with 5 and 6. You can either say angle 3 is equal to angle 4, or you can say 5 is equal to 6. Angle 5 is equal to angle 6 CPCT, but angle 5 and angle 6 are a pair of alternate interior angles made by the transversal CD with the lines BC and AD, and the alternate angles are equal. Therefore, the lines are parallel. AD is parallel to BC. All right. These numbers, as and when you need, you should mark. Not that when you start the proof, you should have marked all these angles. As and when you need, you should go back to the figure and mark. Like when you want 1 and 2, go and mark 1 and 2. So always copy the diagram in your answer paper. And don't think all these numbers and all you should put when you just start the proof. That's not possible. You must start working the proof. As and when needed, you just go back to the figure and mark 1, 2, 3, 4, whatever you want. All right? Okay. I want to explain one of every type in this class so that you understand how to use the criterion. Are you writing? You started writing, is it? Where are you? You just started writing the question? Okay, fine. Write on quickly, all of you. In less than 5 minutes, try to finish it. Now that you understood this, blindly copy it. No, I'll show you this itself.
Completed.
Okay. Done, children?
Yes, ma'am.
Okay. Okay. So in this one, it's given that AB is a line segment. See here, AB is a line segment. And line L, this is the line L, is its perpendicular bisector. Actually, the diagram is not given in the question. I should put this diagram down here in the solution. This is not given. The diagram is not given. Okay, so you need to read the question and draw the diagram yourself. Here, for the first one, the diagram was given. This one, you need to, draw the diagram. So AB is a line segment. Line L is its perpendicular bisector. What do you mean by perpendicular bisector? Where the two lines meet, the angle formed is 90 degrees. And bisector means this is the midpoint of AB. Because L is perpendicular to AB and L bisects AB. So this is the midpoint of AB. So C is the midpoint of AB. Perpendicular means 90 degrees. Bisector means the line segment is cut into two equal halves. See, there is a line segment. There is a line segment AB. And there is a line L. There is a line L. Now, what is the relationship between this line L and the line segment AB? This line L is the perpendicular bisector of AB. That means where these two things meet, the angle formed is 90 degrees. They meet here, no? So the angle formed is 90 degrees. Bisector means this is the midpoint of AB. So C is the midpoint of AB. If a point P lies on L, show that P is equidistant from A and B. P is equidistant meaning the distance of P from A and P from B, you must show that it's equal. P is equidistant from A and B. That is PA is equal to PB. P is equidistant from A and B, meaning you should prove that PA is equal to PB. So now see, it's going to be so simple. If I call this the first triangle and this the second triangle, okay, this side of the first triangle is equal to this side of the second triangle. Why? Because C is the midpoint. It's bisected, no? C is the midpoint. So AC is equal to BC. AC of the first triangle is equal to BC of the second triangle. Then in the first triangle, angle 1 is 90. The second triangle, angle 2 is 90. So angle 1 is equal to angle 2 is equal to 90 degrees. Or you can name it like PCA is equal to PCB. Okay. Angle 1 is equal to angle 2 is equal to 90 degrees. Then you can see that PC is the common side. PC is equal to PC common side. PC is a side common to both the triangles. So it'll be a line segment is equal to itself, right? Like 5 is equal to 5, 6 is equal to 6. So PC is equal to PC. Every line segment is equal to itself. So PC is equal to PC. So if you see in the first triangle, we have mentioned about AC and PC here. AC and PC. AC and PC. So angle 1 is the included angle for these two sides. And the second triangle we have mentioned about BC and PC. BC and PC. And for these two sides, angle 2 is the included angle. See here. For these two sides, this is the included angle. For these two sides, this is the included angle. And that's what we have mentioned. Angle 1 is equal to angle 2. The included angles are equal. So the two triangles are congruent by the SAS. Congruence criterion. Now coming to the order. AC, PC. AC, PC. Let it end with the common letter and start with the common letter. AC, PC. So AC, CP. Then BC and BCN. BC and PC. Which is a common letter? C. So BC, CP. So BCP. Not sure about that. Giant Aditya. Very good. Okay. So we're talking about AC and PC. C is the common letter. So let it end with a common letter. Let's start with the common letter. ACP. ACCP, ACP. Then here BCCP, BCCP, BCP. So ACP is congruent to BCP. So from this you can see AP is equal to BP, CPCP, corresponding parts of the congruent triangles. So that's what we had to prove. We had to prove that AP is equal to BP. We had to prove AP is equal to BP and they're equal through CPCT. This means P is equidistant from A and B. All right. See, instead of you can number, here I've named it ACP, BCP. ACP is this angle, BCP is this angle. You can name the angles like that, or you can just number it angle 1 and angle 2 and say angle 1 is equal to angle 2. Okay. I'll just change these presentations. I'll mark angle 1 and 2 and I'll change the presentation and send it to you tomorrow so that you can copy it. That's easier to revise. Like when you have 1 is equal to 2, it's easier to revise. All right. So in this one, line segment AB is parallel to another line segment CD. Parallel. O is the midpoint of AD, which is AD, this is AD. O is the midpoint, so it's marked here. O is the midpoint of AD, so those two pieces are equal. Show that this first triangle is congruent to the second triangle. Now we have parallel lines, no? So we'll mark the alternate interior angles because we have parallel lines. I'm taking this as the first triangle, this one as the second triangle. So you can see a Z here like this, Z, correct? So if you call this angle 1, it's equal to angle 2 because alternate interior angles are equal. Then you can see another Z like this. See a parallel line, transversal parallel line. So if you call this angle 3, this is angle 4. They equal, alternate interior angles. And then we also have a pair of vertically opposite angles. We have a lot of information. So we also have angle 5 equal to angle 6. So angle 1 is equal to 2 alternate interior angles. 3 is equal to 4 alternate interior angles. 5 is equal to 6 vertically opposite angles. And we also have this side equal to this side. So see children, if you have to prove that these two triangles are congruent, okay, it depends on what. Now there are a lot of things. No, we have 3 pairs of equal angles. That's right, everything. We have angle 1 equal to angle 2. We have angle 3 is equal to angle 4. We have angle 5 is equal to angle 6. And we also have OA is equal to OD. Okay. Can we use SSS? No. Can we use SSS? No. Because we have only one pair of, we have listed all the equalities we have. என்னெல்லாம் ஈக்குவாலிட்டிஸ் இருக்குன்னு லிஸ்ட் பண்ணிட்டோம். ஒரே ஒரு பேர் ஆஃப் ஈக்குவல் சைட்ஸ் தானே இருக்கும். 3 வேணுமே, எஸ்எஸ்எஸ்க்கு 3 வேணும். இல்லையே, நம்மளா சும்மா எழுத முடியாது. ஓகே, ஓபி இஸ் ஈக்குவல் டு ஓசி, ஏபி இஸ் ஈக்குவல் டு சிடி. நோ நோ நோ, யூ cannot just write like that. It should be given, or you should give a reason why you have written that. Either it should be given or you should write a reason. Simply we cannot, just to use SSS, you cannot write all these 3 pairs of sides are equal. But since we have only one S, it can be what? It can be ASA or AAS. Because SS is 3 sides. SA is also 2 sides, 2 pairs of equal sides. RH is not possible. So we are left with only ASA and AAS. You can prove using both. You can prove using both. It depends which information you write. If you write online children, Rahul and Harsha, nobody else is there. Your exams are not over, is it? What do you have tomorrow? Computer science. Yeah. So, yeah, we can use ASA or AAS. Now, if you list two angles on some other side, now this OA is equal to OD. OA is equal to OD. 1 minute. OA is the included side for which two angles in the first triangle? OA is the included side for which two angles in the first triangle? In the first triangle, we have angle 1, we have angle 3, we have angle 5. Okay, let me ask you like this. Which is the included side for angle 1 and angle 3? Eh? No. Which is the included side for angle 1 and angle 3? AB. Which is the included side for angle 3 and angle 5? OB. Which is the included angle for angle 1 and angle 5? OA. Which is the included side for angle 6 and angle 2? OD. Which is the included side for angle 2 and angle 4? CD. Which is the included side for angle 6 and angle 4? This is what included side is. Okay, now, if you want to use AAS, you must write two angles on some other side. Now answer this question correctly. OA, this OA is some other side for which two angles? Okay, let me put it like this, children. OA is the included side for angle 1 and angle 5, right? So it is some other side for angle 1 and angle 3. OA is the included side for angle 1 and angle 5. So for angle 1 and angle 3, it is some other side. OA is some other side for angle 1 and angle 3. OA is some other side for angle 3 and angle 5. That's all. I give up. Now the second triangle OD. Okay. OD. OD is the included side for which two angles? 6 and 2. For angle 6 and angle 2, it's included side. So OD is some other side for which two angles? 6 and 4. And also 2 and 4. அவ்வளவுதான். So நீங்க இப்போ இந்த ஈக்குவாலிட்டிஸ் தான் இருக்கு. இப்ப நீங்க வந்து சப்போசிங் யூ வாண்ட் டு யூஸ் ASA எதை எழுதணும்னா ASAனா கண்டிப்பா OA is equal to OD எழுதியானும். Okay, ASA யூஸ் பண்ணோம்னா OA is equal to OD, you definitely have to write. Yes or no? Yes. Now for OA, which is the included OA is the included side for angle 1 and angle 5. So you should write all this. Angle 1 is equal, angle 1 of the first triangle is equal to angle 2 of the second triangle. Angle 5 of the first triangle is equal to angle 6 of the second triangle. In the information it is ASA. உங்களுக்கு AAS வேணும்னா, if you want to use AAS, okay, some other side. So you should write some other side is OA is equal to OD. This is first triangle, this is second triangle. Now we should not write the include, you should not write the angles, that is, the two angles include OA. No, you should not write those two angles. For OA, you should not write angle 1 and angle 5. You should write angle 1 and angle 3. Or you must write angle 3 and 5. Okay, so you write about angle 3 and angle 5. So angle 3 of the first triangle is equal to angle 4 of the second triangle. Angle 5 of the first triangle is equal to angle 6 of the second triangle. 3 is equal to 4. See, always an angle or a side of the first triangle is equal to angle or side of the second triangle. And the order தான் எப்பவுமே எழுதணும். So இப்ப பாருங்க 3 is equal to 4 alternate angles, 5 is equal to 6 vertically opposite angles, OA is equal to OD given. So now angle 3, angle 5 and OA, two angles, some other side. Angle 4, angle 6 and OD, two angles on some other side. So this is AS. That's all you should write given to prove that. And proof. In proof, you should name the two triangles, this triangle and this triangle, then 1, 2, 3 equalities you should write. நீங்க என்ன ரூல் யூஸ் பண்ணணும் ஃபர்ஸ்டே நீங்க டிசைட் பண்ணிக்கணும். To decide the rule first itself. And based on the rule, you should write the order. So the two triangles are congruent by ASA or AS, whatever, depending on what you've written. So now, how do you disable your mic? How do you name the two triangles? Now, when you have two angles, no, it's very easy. Triangle. If I call it, say BOA is congruent to triangle. B is angle 3, you know. It is equal to which angle? 4. 4 means C. Then O is angle 5. It's equal to 6. That's also O. A is angle 1. It's equal to 2. So D. This is the order. Match the angles and write. This is one way of writing. Or you can write AOB. AOB is congruent to DOC. DOC. Just match the angles and name the triangles. So these two triangles are congruent. These two triangles are congruent. Now you should prove that O is the midpoint of BC. O is the midpoint of BC. That means you should get the result OB is equal to OC. You see here, OB is equal to OC. CPCT. CPCT. OB is equal to OC, CPCT. So that means O is the midpoint of BC. All right. I'll share the images tomorrow morning. Okay, so by the time you come to the next class, you should have gone through the proofs and written, that in the tuition notebook. Practice it in the tuition notebook. What's the ongoing chapter now? After they finished congruent triangles, no, for you? They have started what? They're all formula. They started and we finished this. No, I don't know the chapter number. This one only. Same. Same finished. Huh? They started or finished? Started. For you? Finished. Rahul, is this chapter done in school for you?
Yes, ma'am. I
Completed,
completed
huh?
it.
And what about for Harsha? Harsha is 6. Okay. This chapter, no? I think we stop now because it won't be interesting beyond this. I have some question papers here. Or shall I proceed with this? We'll continue? Oh, oh, very good. Oh, that's good. Okay. That's all. Now that you've got the basics, no? The entire thing is easy because now see here, AC is equal to AD. It's marked here. AC is equal to AD. AB bisects angle A. AB, it bisects angle A. Bisect means dividing something into two equal parts. That means this angle 1 is equal to angle 2. Because this is whole of angle A. It's bisected. That means angle 1 is equal to angle 2. Show that triangle ABC, this one, is congruent to triangle ABD, this one. Okay. Show that this first triangle is congruent to the second triangle. This is angle 1, this is angle 2. And they're equal because this angle A is bisected. It's divided into two equal angles. So what will you write? In the AC of the first triangle is equal to AD of the second triangle given. Angle 1 of the first triangle is equal to angle 2 of the second triangle because it's bisected. And AB is equal to AB. That's a side common to both the triangles. So what's the rule? SAS. Two sides and included angle. Angle 1 is included angle. And angle 2 is also the included angle. So SAS rule, the two triangles are congruent. So what can you say about BC and BD? BC and BD? BC and BD, they're the corresponding sides and they're equal. What can you say about BC and BD? BC and BD, they're the corresponding sides of the two triangles. So they're equal. They're equal. What can you say? They're equal. Okay. So in this figure, ABCD is a quadrilateral. This is the figure given. This is the given figure. ABCD is a quadrilateral with AD equal to BC. And angle DAB. DAB is which angle? DAB, this angle, is equal to CBA. This angle. These two angles are equal. Prove that triangle ABD is congruent to BAC. ABD. I've taken the triangle separately. ABD is this triangle, right? So see here, I've drawn that separately here, ABD. I've drawn that separately, ABD. It's congruent to BAC, which is BAC. BAC, this one. Can you see that I've taken BAC separately here? BAC. Should show that these two triangles are congruent. But you can see from this figure that these two triangles have a common side AB. AB is the common side for the two triangles. You can see from the name itself. ABD, BAC. See, these two letters, AB, BA. So that means that's a common side. The two triangles have a common side. AB is a side. There's a triangle like this, and there's another triangle like this. Okay. And mark carefully angle 1 and angle 2. It's given here, DAB. Which is DAB? This full angle, this angle of this triangle. So I've called it angle 1 is equal to CBA. This angle, CBA is this angle of this triangle. So clearly angle 1 is equal to angle 2. This is angle 1, this is angle 2. Angle 1 is equal to angle 2. And then AB is a common side, no? Both the triangles have a common side AB. And apart from that, we are given that AD is equal to BC. AD is equal to BC. We are given. We are given that AD is equal to BC. Okay, and we know that both the triangles have a common side AB. That we know. And it's directly given that angle 1 is equal to angle 2. It's directly given to you. So in this triangle, it's about this side, and this angle. So two sides include angle. And in this triangle, it's about AB, BC, and angle 2. Two sides include angle. So essays. Now you're going to mention about all these three things. You're going to write AB is equal to AB. That is your S. Then you're going to write angle 1 is equal to angle 2. That is your A. Then you're going to write AD is equal to BC given. That is your S. SAS. Two sides include angle. The triangle congruent. All right. So CPCT. Now you know how to name the triangles in the correct order. I said use the sides. Let it end with a common letter. Start with a common letter. Use that idea and name the triangles correctly. Now here you already have the order. In the question you have this order. So BD is equal to AC. BD is equal to AC CPCT. Because the triangles are congruent, their corresponding sides will be equal. So BD is equal to AC CPCT. Then angle ABD. Angle ABD is equal to angle BAC. See it? Angle ABD is equal to angle BAC. Correct. Angle ABD is equal to angle BAC. When you say angle ABD, you're talking about this vertex B in triangle ABD. In triangle ABD, you're talking about this vertex B. And when you say BAC, you're talking about this vertex A in triangle BAC. In BAC, you're talking about this vertex A. So they're asking if these two angles are, meaning we are supposed to show that these two angles are equal. Yeah, this angle is equal to this angle because CPCT. How? Because see the name. See the name here. B of the first triangle is equal to A of the second triangle. B of the first triangle. See here. B of the first triangle is equal to A of the second triangle. B of the first triangle is equal to A of the second triangle. So CPCT. So both is by CPCT. Both by CPCT. The triangles are congruent. Then BD is equal to AC. BD is equal to AC CPCT because see here. BD second and third is equal to AC second and third. CPCT. Then angle ABD, which is that angle here, ABD, this one. Which is angle BAC, this one. Why these two are equal by CPCT? Because look at the name here. This B is the second letter. And here A is also the second letter. So CPCT, the corresponding vertices. CPCT, that's it. Equal perpendiculars means they're equal. That means, now see here, the line segment is AB. AB is a line segment. CB and AD, they're equal perpendiculars. The line segment is AB. This one, equal perpendiculars. Perpendiculars means they make 90 degrees. And the equal meaning they're equal. So AD and BC, they are equal perpendiculars to the line segment AB. Show that CD bisects AB. Show that CD bisects AB. So CD bisects AB. CD cuts AB into two equal pieces. Which is bisected, CD or AB? Yeah, so show that CD bisects AB. CD is bisecting something else, AB. So AB is bisected. So you should prove that O is the midpoint of AB. Bisects AB. So this is AB. So you should prove that O is the midpoint of AB. In other words, you must prove that OA is equal to OB. OA is equal to OB. You must prove that OA is equal to OB. If you prove OA is equal to OB, that means O is the midpoint of AB, which means AB is bisected. Okay. So see here, vertically opposite angles. Angle 1 of the first triangle is equal to angle 2 of the second triangle. Correct? Then this one is equal to this one. The side of the first triangle is equal to the side of the second triangle. And then in the first triangle, this is 90 degrees. In the second triangle, this is 90 degrees. So you can see this is A, this is A. This is the included side, OA. But no, we have mentioned AD. So it is two angles on some other side. Two angles on some other side. We have mentioned about angle 1, angle 2, angle 3, and angle 4. 1 is equal to vertically opposite angles. 3 is equal to 4, 90 degrees. Then, if you're talking about the included side, you should write OA is equal to OB. No, that information we don't have. We have written AD is equal to BC. So it is clearly two angles and some other side AD. Two angles 2 and 4 and some other side BC. By AAS rule, the two triangles are congruent. You understand why it is AAS? Yeah. 1 is equal to 2, 3 is equal to 4, and AD is equal to BC. So it is two angles and some other side BC. Two angles 1 and 3 and some other side AD. So AAS rule, the two triangles are congruent. The order is, if you write OAD, that is 1, 3, OAD. What is 1 equal to here? 2, so O. And then 3 is equal to 4, that is B, OBC. Match the angles. This is angle 1, this is angle 2. Angle 1 is equal to angle 2. This is angle 3 equal to angle 4. So from this, you can see OA is equal to OB. OA is equal to OB. OA is equal to OB, CPCT. So if OA is equal to OB, that means O is the midpoint of AB. I'll do this and stop. Then we'll just work some other question, meaning we just revise a few questions from this paper which I have. Now, this one can be proved using, many, I think except RHS, you can use all the other conditions, except RHS. So here we are given that this line L is parallel to line M and line P is parallel to line Q. Okay. Now we know that in a quadrilateral, when both the pairs of opposite sides are parallel, this side is parallel to this side. Sorry, this line is parallel to this line and this line is parallel to this line. L is parallel to M, right? And what is AD? It's a part of L. What is BC? It's a part of M. If L is parallel to M, AD is parallel to BC, right? Similarly, P is parallel to Q. P is parallel to Q. What is AB? It's a part of P. And what is DC? It's a part of Q. A part of Q. So if P is parallel to Q, AB is parallel to DC. So you can see that in quadrilateral ABCD, both the pairs of opposite sides are parallel. So ABCD is a parallelogram. And in a parallelogram, like in a rectangle, opposite sides are equal, opposite angles are equal. In a parallelogram, like a rectangle, opposite sides are equal, opposite angles are equal. Okay, so now let's mark all the information we have. Opposite sides, now ABCD is a parallelogram, right? ABCD is what? It's a parallelogram. So this side is equal to this side. This side is equal to this side. Opposite sides are equal. Opposite angles are also equal. So that means this angle is equal to this angle. Also this angle, but this angle is like half in one triangle, half in other triangle. So we will not take that. You take information which is completely in one triangle or the other triangle and the other triangle. Like not this, we'll not use this. This angle equal to this angle. Anyways, we can't use because a part of it is in this triangle, a part of this is a part. Okay, a part is in one triangle and the remaining part is in the other triangle. So we'll not use that. I'll mark again. This side is equal to this side. Opposite sides are equal. Opposite sides are equal because it's a parallelogram. Opposite angles are equal. Now let me call this angle 1 and angle 2. And then we also have z's happening here. You have a z. So that means this angle 3 is equal to angle 4. Alternate angles are equal. And you have another, z like this or n like this. So here we have angle 5 is equal to angle 6. So much we have. Now, if you want to use SSS, see, they want you to show that the two triangles ABC this triangle is congruent to this triangle. Okay, show that these two triangles are congruent. All right. If you want to use SSS, if you want to use SSS, you must say AB of the first triangle is equal to what? Huh? CD or DC, anything, both are fine. AB of the first triangle is equal to DC of the second triangle. Then BC of the first triangle is equal to BC is equal to AD of the second triangle. And then AC is equal to AC common side. AC is a side common to both the triangles. SSS, that's all finished. If you want to use AAS, angle 1 of the first triangle is equal to angle 2 of the second triangle. Then say anything else. Angle 5 of the first triangle is equal to 6 of the second triangle. Why? Alternate interior angles are equal. You must not say of the same triangle. Angle 5 of the first triangle is equal to 6 of the second triangle. Alternate interior angles are equal. Now, which is the side included by 1 and 5? Which is the side included by 1 and 5? AB. Don't write about AB. Write about anybody else, but don't write AB. Then only it will be AAS. Two angles on some other side. Because angle 1 and angle 5, they include AB. Don't write about AB. Write about anybody else. So that means we'll write about, you can write AC is equal to AC. For in the second triangle, which is a side included by 2 and 6? Second triangle, which is a side included by 2 and 6? DC. Don't write about DC. So we have not written about the included sides. AC is equal to AC. You can write AC is equal to AC, or you can write BC. You can write BC is equal to AD. BC is equal to AD. Some other side. AAS. But if you want to make it ASA, if you want to make it ASA, okay, Nariya idala. Again, see, you can write angle 5 is equal to angle 6. You can write angle 4 is equal to angle 3. Both alternate interior angles are equal. Then, which is a side included by angle 5 and angle 4? AC. Which is a side included by angle 6 and 3? AC. This is ASA. Another way of writing ASA is just write any pair of equal angles. If you write, like, say, angle 1 is equal to angle 2, and then angle 4 is equal to angle angle 3. Angle 4 is equal to angle 3. Okay, if you write angle 1 is equal to angle 2, opposite angles are equal. In a parallelogram, opposite angles are equal. And if you write angle 4 is equal to angle 3, alternate interior angles are equal. So, which is the side included by angle 1 and angle 4? BC equals, which is the side included by 2 and 3? AD. So, you must write BC is equal to AD. Yeah, BC is equal to AD, no? Opposite sides are equal. Like this, you can go on in a few more ways. So sometimes you'll have so much of information that you can use, like here, see, we've used all the congruence criteria except RHS. And ASA also you can do it in different ways. AS also you can write in 2 or 3 ways. So like that. You can use SAS, you can use SSS. Everything is correct. We have a lot of information. But to use all this, you must prove that ABCD is a parallelogram. Why is ABCD a parallelogram? Because both the pairs of opposite sides are parallel. Because both pairs of opposite sides are parallel, it's a parallelogram. And when it's a parallelogram, like a rectangle, opposite sides are equal, opposite angles are equal. All right? Okay. Simple question. Now, if 343, that's it. We'll pass congruent triangles here for this class. Okay, we have 5 minutes more. We'll just discuss something else. So we have 343 to the power 2 by n equals 49. Find n. Yeah. So this, you can just roughly, yeah, if you ask me paper. Yeah, just use the last page of your book work and tell me what's the value of n.
Ma'am,
Yeah.
n is equal to 2.
2. Okay. So 343 is 7 cubed into 2 by n is equal to 7 squared. So 3 into 2, 7 to the power 6 by n is equal to 7 to the power 2. 6 by n is equal to 2. 2n is equal to 6. N is equal to 3, no? Let's slowly, 1 minute. I'll just do it again. Same thing, I'll do it again. 343 to the power 2 by n is equal to 49. So 343, 7 into 7 into 7, 7 cubed. And then there's this power 2 by n. So you should multiply the powers. When there are many powers, multiply the powers. Is equal to, what is 49? 7 squared. 49 is 7 squared. So 7 to the power 3 to the 6. 6 by n is equal to 7 squared. Now bases are same. So equate the powers. 6 by n is equal to 2. Cross multiply. 2n is equal to 6. N is equal to 3. How did you get 2, Rahul?
Ma'am,
Yeah, how did you get 2?
ma'am, I take the 7 to power as 2, ma'am, not 3.
Okay.
A power mistake.
Okay. Okay, which of the following is irrational? Which of the following is irrational? All of them, right? Irrational. Which of these is irrational? Root 5 plus 3. What about the first one? Okay, so square root of 16 is 4. 4 minus 4 is 0. Rational. Second one is like a plus b into a minus b. A squared minus b squared. A minus b into a plus b. A squared minus b squared. 3 squared minus root 3, the whole square. Correct? Yes. So 9 minus 3, which is 6. And then square root of 25 is 5. So 0 is rational, 6 is rational, 5 is rational. This one is irrational. Root 5 plus 3. What is root 5? It's an irrational number because it's non-terminating. It has a non-terminating, non-repeating decimal expansion. Plus 3 will be another non-terminating, non-repeating decimal expansion. So C represents an irrational number. Yeah. Got it? Yes. All right, children. So that's it for today's session. Thank you so much. Thank you, online children. You may leave the class. Good night.
Thank you, ma'am.
Thank you. Good night.